What's going on, builders? My name is Kevin, and today we're going to be going over the Git essentials that you need to make your software development projects go a lot smoother. Let's jump in. So we're going to be covering why Git, why do you need to use it, go over a few core concepts that make it much easier for you to use and understand Git now into the future. And then we'll do a live demo on how you would use Git in your normal workflows and also how you would collaborate using Git with a larger team. And then along the way, we're going to answer a few practice questions just to stay sharp. So to start, why does Git exist? So if you think about Git and your code like a edit or a version of a paper or some other file that you're editing, you can think about when you're saving multiple copies and how cluttered your folder or your desktop may get when you have to keep resaving the same file under different names. And assuming you want to keep history and keep the old versions in place. Now imagine doing this for thousands of lines of code and doing this with dozens of developers that are helping you to build and making edits and revising things. Like that can get very chaotic very fast, and it becomes a very difficult environment to work reliably in. Excuse me. So think about Git as solving some very important problems. One, how do we get back to the last or best known version of this project, of this code, whatever it may be? How do I go back? Then how do I manage to merge any conflicts or manage any conflicts when I'm making a change to a file that my peer or my teammate is also making a change to? What do we do in that scenario? Git will be very helpful. And then most importantly, Git will tell you what changed, when it changed, and who did it. And this is going to be helpful for auditing, for again, going back to a working change, understanding the why behind the development of a project over time, right? Every project, every piece of code is a work in progress, even if it's been here for years. So having that history in place, having that log in place is going to be super helpful and useful for you. So one quick thing to cover before we really jump in is the difference between a local and a remote repository. Your local repository is going to be your computer. This is where you're actually executing the code, writing the code, and doing your thing. The remote repository is going to be that cloud resource, that cloud repo that you use to actually, and you and your team use to store code reliably, to push and pull code from. And this is going to be like your cloud backup that everyone is using versus that local repo is only accessible to you. You can make changes, you can break things, but you can always get back to the last known version or the last known versions inside of that centralized repository, that remote repo. So we won't go too in depth in this video on the different remote repository options. There are many, some you may be familiar with, but we're not going to talk about that today. I guess it is worth noting that Git is not the same as GitHub or GitLab. These are different things. But whether you're using whatever repository that you're using for your remote repository, uh, Git is going to be the underlying tool and technology that is making that work, that's making the workflows happen. So let's think about Git and the core concepts from a time machine mental model. Or if you even if you're a fan of anime, think about mangas and you have different timelines. You might have something that's canon and then something that's more like a community story. It's not part of the main storyline, but it's worth knowing or it's based off of the main storyline. That's going to be your repository. Well, your repository is again the folder that is being tracked by whatever repository you're using. That is everything that exists. That's all the files, the full history. They all live inside of that repository. And so when you get your local repository, you have the copy of that timeline, of all those files, all that full history inside of your local computer. But the main backup, the main timeline with everything that's always going to be stored on your remote repository. And so repository equals the project. That is the world that we're describing. Now your branch, think about a branch as an alternate timeline inside of your project. Your project may have multiple different versions, multiple different branches that all are slightly different. And some of them are going to be built from the same history, but then some of them will diverge in different ways. That is a branch. Every branch is based off of the history, that main line, but then they can go in different directions. They can have different names and they can grow in parallel or perpendicular really to each other. So think about that. And you can create a new branch without affecting everyone else's version of that project. That's one of the most useful features of Git and branches. A commit is a snapshot, is a point in time inside a particular branch. So your branch will have different commits, and these commits have unique identifiers, usually going to be called your commit hash. And you can save a message with a hash, but basically it is a snapshot that says at this point in time, this is what this branch or this file looked like inside of this repository, inside of this branch or on this branch, right? Every branch may have its own commit history, may have its own commits. A commit is going to be unique. So even if you change one thing inside of a commit or inside of a file inside of your project, it's going to generate a different commit hash versus that same commit or that same change being made on a different branch or a different file. Then your working directory. This is a concept that's primarily on your local repository. When you're working on your local repository, you can go into the file system and update a particular file. That file that is currently checked out, or that branch that is currently checked out that you're working on, that is your working directory. That is where you're making your changes. That is if you were to go through your file system and say, open this file. This is the version of the branch that is active, or the version of the repository project that is active, your current branch that you're actively editing. And this is important to understand. When you're making changes to your working directory, that doesn't change anything about the history. That doesn't change the entire project, um, the way it's built. And then we have a staging area. The staging area is like a holding place where you store your changes that are ready to go and ready to get committed, but you haven't yet decided or you haven't actually shipped them out. So think about it like a holding area for packages. You have to box your item before you ship it out. The staging area is your packing it inside of the box and then checkout. When you're trying to move from one branch to another, then you have to check out. You have to you have to jump from this timeline to another timeline. That's all a checkout is. So we're not gonna spend too much time on these definitions, but just wanted to throw them out there right now, just so you have a little bit of familiarity as we get further along. We're gonna actually just start and jump into the code for now. All right, so I'm currently inside of my terminal. Do not be alarmed if you haven't spent too much time inside of your terminal. I am in my projects directory. This is where I store most of my code, most of my tools, whatever project I'm working on, I store them in here. So we're gonna start by creating a new repository, a new project. So if you were to be starting from scratch, then you would first create your directory. Let's say you're working with React or with Python, whatever it might be. You start with a folder. If you're using React, you would use the create or React, I think it's npx create React app command, and it would create that folder for you. Same for most projects that you may use. You create that initial folder first. So I'm going to do that from the command line here, and we're going to call it uh, brand new project. So now I should see brand new project inside of my folder. So let's jump in there. And now we're inside of our brand new project. This is just a folder. The fun part with Git happens after you run git init. Git init is going to initialize an empty Git repository, like it says, at this directory. And this repository is a local repository because it only exists on my computer at this moment. But now that it's tracked with Git, there's some very cool things I can do. So I can, let's say I create a new file. Um, mm, and I want to, right, I have this new file. You can see in my ID, my terminal, I have some indicators to let me know that things have been changed. But uh, at this point, I created a new project, started tracking it with Git, and then I added a new file. Now, if I look at Git status, this is going to show me which, basically the status of my branch. It's going to tell me which branch I'm on, what commits are in there, or what current commit I'm on, if I had some other commits, and then it's going to show me some of the files that are tracked or untracked. Remember, tracked files are our working directory. This is where we're at right now. Versus if I had added things, they would be in my staging area. Right now, README is inside of the working directory, but I want to add it to a new commit. So I'm going to do git add. By putting the git add plus the period. The period is basically everything in this folder, but I could also specify the file itself. If you have some other files that you don't want to actually include inside of this commit, then you can use this exact file name. If you want everything that exists in this file or this folder, then you use the period. But we can just use the README name for now. And let's try git status again. So now you see we have changes to be committed. That means these changes are now inside of our staging area. That means the next time I run git commit, these changes are going to be included inside of that commit. Versus if I were to add another file, let's say I uh, create a new file. And in here, some very something simple. Now git status. So now we have two different types of files or two files inside of this directory. One is I'm gonna run git status is saying changes to be committed. That means that change is inside of my working directory, but it has not yet been tracked. So it's not yet in my staging area, right? Or excuse me, changes to be committed are in my staging area. And the untracked files are in my working directory, but not inside of my staging area, right? So if I were to run git commit, the README would be saved, but not the main.py file. Let's try that right now. Git add, or no, not git add. We don't want it to be included. We're gonna do git commit. And with every git commit, you can and you need to leave a message. If you can provide the -m flag, and then you can provide the message inside of the command here. So let's say our first commit. One of the most important things to think about as a professional engineer is the commit messages that you create in your projects. Every message that you leave is a reminder to you and a tool for you to help understand how your project is developing, how it has grown from the beginning to whatever time point you are in right now. So best practice is to put in very clear and specific commit messages as much as possible. Our first commit is literally our first commit, so we're not gonna go too deep into it. We didn't do much, but as you start to get into bigger projects and as you start to make larger changes, you want to make sure you're being very specific about what you put and what you did during this exact commit. So let's do that now. And so we see that a few things have outputted, right? We see the number of files that were changed and exactly how many lines were changed. So we see one file changed and 3 insertions. That means we have 3 lines that were added. Uh, and then it even says like the exact file that was added. So now if I run git log, I'm going to see our commit history. And this long string is what a commit hash is. So this is going to be globally unique to your project, and it's going to have a lot more information like the author of that commit, the date, and then also our commit message that we included. It also will give you an indication about, what branch this log or this commit was included with. So let's get out of there for a moment. And that's pretty much the standard format that you're going to see for working with Git. That's what your workflow is going to look like. That's only if you're starting from scratch. We'll go a little bit deeper into how you would collaborate with Git in a moment. Just wanted to do a little bit of a test for you and me to see how we could test our Git understanding. So you edited a file and want to include it in your next commit. What should you do first? We're going to say git add, right? Because you edited the file and you want to commit it. So now you need to put it inside of your staging area. The only way to move a file into the staging area is to add it to the staging area. In the time machine mental model, what does a branch represent? This represents a alternate timeline where you can try new things. So my branch can be on a timeline where the print statement was not used, or where the main.py file exists, where my fellow dev can be on a branch or a timeline where the README doesn't exist, where some other file exists, but not the one that I'm using, right? These different branches can be very different depending on how long they've lived separately and what types of changes the development team has added to them over time before, syncing them back up. Which command shows you the current state of your files, what stage, what's changed, and what's tracked? So that's our git status, right? Uh, we will go into the git diff later on, but the git status is going to give you a very high level overview of what is going on right now. What is my branch looking like? What is my working directory looking like? What is my staging area looking like? What does git init do? So git init is that first command that we ran to actually turn our folder into a Git project or Git repository to use the more accurate terminology. All right, then there are a few commands that are very important for working and collaborating with others. and even, yeah, I would say working with and collaborating with others that you're more likely going to use on any of your uh, professional projects. So let's jump back into the terminal to go over and practice with these. All right. So first things first, I'm going to get out of this repository. We're going to be going back to our projects folder. And when you are working with others, you're going to be coming in usually as a developer on a team that already exists. The product already exists. The project already exists. So you don't usually have to create your own repository. You're going to clone the repository that your team is working on. So let's do that now. I have a project that I've been working on with my company, and for my company, it's a tool that I've built to help me, automate some of my work. So we're gonna clone that here because I haven't actually worked on it on my personal computer yet. So generate burn down report. That is the project. So git clone, and then you provide the URL to this remote repository. My repository is GitHub. Your repository may be GitLab, it may be Bitbucket or whatever repository your team actually uses. The main command here is git clone. Git clone is going to create a folder locally with the same name as that repository, and then it's going to pull in all of the files, all of the branches that exist inside of that remote repository, and it's going to clone them, copy them to your local repository, to your computer. So now if I open this up, ls, I will see generate burn down report inside of my folder. Let's jump in there real quick. So I see that I'm on the master branch, and you see it's already a Git repository. It's already being tracked as a Git repository. And then we can see what branches exist on here. Git branch. Oh, it's only one it's saying, but there's definitely more. Ah, hmm. Hmm. Definitely more branches. Gotta check that out. Okay, so interesting thing is it's not showing me all of the branches that are remote are in the remote uh repository, but there is a branch called, oh, it's definitely not even allowing me to get to it. That's very interesting. Yeah, this is like a tutorial for both of us. Uh, I did not have this issue before. Hmm. Hmm. Get checkout. Yeah, I think I did get branch. I was supposed to do get checkout. My mistake. All right, so now if I run git branch, you'll see that that branch is now included in our history. Uh, Interesting thing here, when I cloned the repository, it did not actually pull in all of the branches that existed inside of that source repository. So that's something to keep in mind. You will still have to know that the branch exists in order to clone it or check it out locally, but it does exist, right? Even though I didn't see it. So your git branch, think there's probably a command for that. Git branch help. Eh, mm, All right, so option A would have shown me both the local and remote branches. That's the only thing. All right. Just wanted to highlight that there, just so something you can keep an eye on in case you're ever looking for a branch that you expect to be locally, but you don't see it when you run git branch. You can always just run git checkout and specify that branch name, and then you'll get to it. Or if you want to see it before you check it out, see if the different options, then you would need to run git branch dash A, which will show you all of the remote branches, right? So we had a few more than even the ones that we were seeing at first. All right. So now that we see our branches and we can check out a branch, I actually want to check out git. I want to go back to master. Git checkout master. So going back to master, and I want to create a new branch. Now, there are a few ways to create a new branch in Git. You can do git branch and then give the branch name, or you can do git checkout with the dash B flag and provide that new branch name. I'm gonna just use git checkout for now. Git checkout, update readme. Now in update readme, I want to check if we have a readme. We do. So let's print. Let's go in here real quick. All right, so we just have the title of the project in our README. That's not very helpful. That doesn't help anyone. So let's go inside and add a little bit more to that README. Right. Uh, Gotta get out real quick and then come back in. So this is a very specific description of this project, right? And so I added this to our README. And then with Vim, you have to always do WQ. So specify that you want to write the file and save the file, not just write in it. And then if you quit, it deletes your changes. So it doesn't even save your changes. So WQ to actually save it. And then now, again, we have our indicated to see that something changed inside of our working directory. So we can look at what changed right here. So inside of our working directory, a change that has not been staged for commit is the README has been modified. And it also says no changes have been added to a commit. So let's fix that. Let's do git add and then git commit. Then we're going to say update the README. All right. So we committed our change. Now, if we go to git log, we'll see our new commit onto our history, right? So get out of there. And then now we have a brand new branch that has our change that we want to save. But right now, that change is only inside of our timeline, only inside of our update README timeline. This doesn't exist anywhere that the rest of the team can use. So we have to merge it to master. And I'm also going to go ahead and merge an existing PR that I had opened that was opened by double C, Claude Code. I like to call him double C. But I'm gonna show you something that's really important to keep in mind when you're collaborating with a team and working across different branches. So we just made our commit to the update README branch. Now we're gonna go to git checkout master because we want to get back on our master branch. All right. Now it says that our branch is up to date with origin master, but before you merge any type of code, you should always make sure you're on the most up-to-date branch that is coming from the central repository, because you don't want to start merging changes to a branch that's stale. So you should always run a git pull. Git pull is going to pull the latest changes for that branch to your local branch, or from the remote repository version of that branch to your local repository version of that branch. So we can see that our master branch has changed. We have one file that has changed 18 insertions. And then now we want to merge my dogs, man. We're gonna merge uh our update README branch to this master branch. So we're gonna run the git merge command and then provide that branch. And then because a merge is basically a commit, right? From you're pulling all of the commits that don't exist inside of the current branch's history. You're pulling those from the branch that you're merging with. So we have our one commit that we included just now, updating the README. That needs to be coming over, and then the merge needs to count as its own uh, commit. So I'm gonna keep this default commit message that it has. We're really just merging the branch update README to this branch. We're merging the commits from update README to this branch. So that's good. WQ, and now we have our merge right. And then if we look at the git log, we can see that we have not only our commit from update README, and we can even see that update README is still at this commit. That's as far as it's gotten in its history. But we also have the merge that came from double C when that PR was merged. And then we have our merge from merging the update README branch to our master branch. So those came in as different logs and different changes inside of your history, different commits, different snapshots in time. And then now that we have our branch merged and where it needs to be on our local repository, we have to get this back to the central repo so that everyone else can, take advantage of our latest history, that they can access and read our README. So let's go there. So git status is if you run the Git status after your merge, you'll see that Git is telling you your branch is ahead of origin master by 2 commits. So we have to push our changes to get them into the repositories. Let's run git push. Git push has pushed those changes back up to our remote master branch now. And so everyone else on the team is able to take advantage of our code and start working with it on their devices when they start pulling from this code. So that's pretty much everything you would need to do with Git getting started, right? We walked through checking out a branch, creating a new branch, adding some changes to your staging area, editing them inside of your working directory, committing a change, logging what changes are in your branch, and even merging a branch to another. And then you also saw how we can push and pull changes from our remote repository. That's really all you need when you're working with Git. You're going to use these same commands a dozen times a day. And so just get familiar with using them, get familiar with, what you need to do when you're using them, and just being comfortable playing around with the command line and using Git in your project. So we're gonna kind of end it off right here. Some things to keep in mind moving forward when you're thinking about Git and how you need to use it inside of your professional career. One, you should definitely create a GitHub account. I mentioned that Git is not the same as GitHub, but GitHub is a very useful tool for developers to kind of explore what you can do beyond just Git, beyond just version control. GitHub is your, very easy to use public repository or code repository, remote repository that you can use to host your source code, collaborate with other people and developers, and it's a great tool for sharing your work. Read the Git docs. If you have Git installed, you can always run Git help, and it'll whatever command you are wanting to get more information from, or even I ran it earlier. If you run Git, like whatever the command is, dash dash help, it'll give you a quick breakdown on the different flags available for that command. And practice your learning Git branching and look that up with whether with your favorite AI tool or even just Googling, how get different Git strategies work. And then play around with, working with others, play around with checking out your friend's code, pushing some code, creating a PR, and doing all that with GitHub or with, well, the PRs with GitHub specifically, but, making changes with your friends and with other projects that you don't specifically own, just so you can see what it's like to work on a team and have to merge conflicts and or yeah, have to fix merge conflicts, have to, you know, uh keep track of branches that are kind of old and stale and eventually push them back together and just get familiar with the next level of just learning Git. But for now, to start with practicing these commands that I shared, and good luck. It's definitely a journey, but getting started with Git is a great place to start. So I'll peace out. Later, builders.